Hello everyone, welcome back to the GRE Math review series. Today we'll be doing the fourth topic in the series on ratio and proportions. Let's get started. So what are ratios? Well, ratios are just like fractions, but there's one important difference. So fractions, if you remember, they kind of refer to parts. Oops, let me write that again. Parts of a whole. So like the example for pizza, if you have 6 slices in a pizza and you eat 2 of those, you will say you ate 2/6 of the pizza, 2 out of 6. Now, a ratio is different in the sense that it actually refers to parts to parts. So both the numerator and the denominator refers to parts. There's no mention of wholes. So best way is to look at an example of this. Right. Let's say we have a jar full of marbles. We have red marbles and we have blue marbles. Okay. So 5 red marbles. Oops, let me write that again. 5 red marbles, 7 red marbles. Now, if I were to write a fraction, I would say, or let's say if I want to write a fraction of red marbles in the jar, well, I would take the number of red marbles, which is 5, and divide by the total number of marbles, which would be 5 plus 7. That will give me 5/12. Right? So again, we have parts. So part here is red marbles over whole. Whole is all the number of marbles. And we get this fraction of red marbles in the jar. Similarly, for fraction of blue marbles, we would get 7/12. Alright. So what about ratios? So let's say one common way a ratio would be referred to is ratio of this to that. So in this example, let's say we call ratio of red marbles to blue marbles. So we know this is the red marbles are 5 and blue marbles are 7. So the ratio we call it is 5/7. And the way to write this is with a colon instead of a 2. So you write 5/7. And in fraction terms, you can write this as 5/7. So important thing to realize here is that this ratio has both parts in the numerator and denominator, just like I have written over here. It's a part over part fraction instead of part of a whole fraction. Right? Okay, let's do some examples to get this ratio terminology more, what ratio represents more clear. So one particular type of problems you'll be looking at on GREs is where you're going from a ratio to a percent. So let's say there's a cricket team and the ratio of their win to losses. So ratio of wins to or win to loss. So this ratio is 7/3. Okay. So for every 7 games that this team wins, they also lose 3. Right? So if I want to just write this in fraction terms, this would be win over loss. This is just 7/3. Okay. Now if I want to write a percent, so if I want to write %1, then if you remember the percent formula, whatever quantity whose percent you want to calculate, you write that in the numerator, so that's 7, and the total goes at the bottom. Just such like a regular fraction, the total here is 7 plus 3. So that's 7/10. In percent terms, that would be 70%. Okay, so that's how you go from a ratio to a percent. One thing about ratios, this 7 to 3 ratio does not tell you anything about the total number of games that this team played or won or lost. This is just a ratio, so you don't get any information about total games. So the total games could be any multiple of the 7 to 3. So if I multiply 7 to 3, the 7 to 3 by, let's say, 2, I would get, so if I times it by 2, I'll get 14 and 6. So this could be the number of games. So it could be 14 won games, 6 lost games, right? If I multiply this ratio by 5, I'll get 35 to 15. This could be the ratio 2. So a ratio by itself does not give you any information about the total things that might be present. So this was going from a ratio to a percent. How about we go from a percent to a ratio? So going from a percent to ratio. Right. So let's say in a particular school, 45% of the students are male. Okay. So I want to know what's the ratio of male to female at the school. Okay. So with these questions, it's always good to start with assuming total number of students. So assume there are 100 students in all. Okay, and 100 is a good number to start with because with percents, 100 is very easy to work with. So if I have 100 students, 45% of that is 45. So I know 45 are male and 55. My pen is having trouble today. So 55 students are female. Okay, so now the ratio is simple to write. So ratio of, I want to find male to female, so that would be 45 to 55, which I can simplify to, so 5 times 9 gives me 45, 5 times 11, so I get 9 over 11. Okay, pretty simple and straightforward, I hope so. Let's do some actual GRE problems from your book. Here's the first one. If the ratio of, let me select the right pen first. If the ratio of men to women in a particular dormitory is 5 to 3, okay, so they tell us the ratio, which of the following could not be the number of residents in the dormitory? Right. So again, just to re-emphasize, a ratio does not tell you anything about how many men or women are in there, the absolute number of men or women, or the total number of people living in this dormitory. The only thing you know is that the men to women ratio is 5 to 3. And the question is asking which of these could possibly be the total number of residents in the dormitory. So there's very systematic ways to attack these problems. So first is basically you take your ratio numbers, so 5 and 3 in this case, and you add them up. You get 8 in this case. So 8 is like the total, it represents in a way the total number of men and women in the dormitory, but it's not actually the number of men and women, right? In fact, what happens is that the actual number would be a multiple of this number. So the actual number of men and women could be, let's say, 8 times 9, 72. So 9 here is the multiple, and it could be that there might be 72 people. But what's important is that any number that might be the number of residents, it has to be a multiple of 8. Okay, so in your choices here, you're looking for numbers that are not multiple of 8, since it's asking which of these could not be the number. So we know 24 is a multiple of 8. 8 times 3 is 24. 40 is also a multiple. 8 times 5 is 40. 96 is also a multiple. 8 times 12 is 96. 150 actually is not a multiple of 8. And 224, well, that's also a multiple of 8. You should check that. Okay, again, so you take your units, you take the ratio and add them to get this 8 units, and basically that is the multiple that you're looking for in the answers here. 8 has to be a multiple of these numbers. Okay, or actually to say it correctly, these numbers have to be the multiple of 8. Right? Moving on to the next one. The measure of two acute angles in a right triangle are in the ratio of 5 to 13. What is the measure of the larger angle? So some terminology you might not be familiar with it yet because we have not done geometry yet. But just to remind you, a right triangle is any triangle where one of the angles is a 90 degree. So this sign usually represents a 90 degree. So whenever you see that, you mean you have a right triangle. Well, then you have two other angles remaining, and these two angles in a right triangle would always add up to, so let's say these angles are A and B, then A and B would always add up to A into 90. Okay, so the sum of all the angles in a triangle is 180. It's 180. One of the angles we know is 90, so the other two angles have to sum up to 80. All right, so we know these two angles, they have to sum up to 90, and we know the ratio. So we know A to B is 5 to 30, right? And the question is asking what's the measure of the larger angle. So the angle that's represented by the number 13 in this ratio. Again, a very usual ratio problem. Again, you start out by taking the sum of these ratio numbers, 5 and 13, and you get 18. Now you know that these two sum up to 90, so there's a particular relation between this 18 number and 90, and you'll see that 18 times 5 gives you 90. So this 90 is your multiplier in this question. Basically what you do is then you take this multiplier, you multiply your ratio by it. So 5 times 5 gives me 25, and 5 times 13 gives me 65. So these are your angles, actual angle values. So 65 being the largest is the correct answer here. So again, this conversion is important, this conversion. So using 5 and 13, you find 18 to be the unit that represents the total in this case, which was 90. So then you can find your multiplier, which is 5, and use that multiplier to back out your actual angle measures. Okay. Now, before we go on to the next question, you can also have more than two quantities represented in a ratio. So up till now we had just two numbers like this in a ratio, right? 2 to the 3. But you can have more than two. You can have another quantity in the ratio, another one. You can have infinite number of these. Okay. But the process remains the same. Like when we added these to get to this multiplier, you can do that with any number of quantities. Okay, next question, where we'll actually use more than two quantities in a ratio. So jar A and jar B each have 70 marbles, all of which are red, white, or blue. So the jars have three colors of marbles. In jar A, red, white are in the ratio 2 to 3, white, blue is 3 to 5, jar B, red, white is 2 to 3, and white, blue is 4 to 5. Okay, column A wants us to find the number of white marbles in jar A, column B is number of white marbles in jar B. Alright, so let's start with jar A. So jar A, we know red to white is 2 to 3, white to blue is 3 to 5. So here we need to actually set up a 3 quantity ratio. So instead of just 2 of these, we want to have the blue here also. So the way to write that is that basically you want to have this ratio. And you know red to white is 2 to 3, right? Red to white is 2 to 3, so we can write that as it here. Now the question is, what do you write for blue in this 3 quantity ratio? So Well, if you look at the white to blue ratio, you again have 3 for white, which is what you have here. Well, so then it means it's the same ratio. If that number was different, then you will have to do something else, which actually isn't the case of jar B. But just with jar A, it's simple, since the ratio value for white marble is same in both this ratio and this ratio. Okay, so the process is the same. Then you take your ratio values, you add them up. So this gets me 10. This 10 represents the total marbles in the jar, which is 70. So my multiplier is 7 in this case. Now I want to find white marbles in jar A. White marbles are represented by 3 in this ratio setup. So basically for white, I have to do 3 times 7, I get 21. Okay, so 21 in column A. Now I have to do the similar thing, similar ratio for B. But you'll realize that in B, the first ratio is 2 to 3, but the number of white in the second ratio is 4. So this number and this number is different now, and you have to make them same. So the simplest way is to basically cross multiply. So multiply the first ratio by the number of whites in the second ratio. So 4, 2 to the 3. And the second ratio by the number of whites in the first ratio. So that's 3. So 3 times 4 to the 5. Okay, so here you'll get 8 and 12, and here you'll get 12 and 15. Okay, so your ratio would be, so for red now I have 8, white is 12, right? 12 here, 12 here. Now we have made white same, and for blue I have 15 now. Okay, so again you add up these ratio values. Oops, I have to add them up. So this will give me 35, and these 35 represent the total in the jar, which is 70. So my multiplier in this case is 2. The number of white marble, the value that represents white value in the white marble in the ratio is 12. So I take 12 times it by my multiplier, which is 2, and I get 24. Okay, so for column B I have 24, and that's the bigger quantity. Correct answer is B in this case. Alright, so next we'll do proportions. Proportions are very much like ratios. Only proportion actually means when you have two ratios and that are equal to each other. So let's say you have a ratio of 2 over 3, and you have a ratio of let's say 10 over 15. These two ratios are actually the same. And why are they the same? Because if I simplify this, I'll get 2 over 3. So whenever you have two ratios that are equal, so 10 over 15. So whenever you have two ratios that are equal to each other, they are called as a proportion. So I have here 2 over 3 equals 10 over 15. Right? So this is known as a proportion. This comes in handy when there's one of these four values is unknown. Okay, so we'll see an example of that. But right now, just the definition that you have two ratios that are equal to each other, and it's known as a proportion. If I represent these numbers in my proportion in letters, so let's say A, B, C, D, one good technique to know is cross multiplication, which can help you simplify and solve many of these problems. So I think we have done this earlier in the fraction section. Basically you cross multiply and end up with this equation: AD equals BC. So this many times helps, especially when one of these values is unknown. Let's do a problem to apply this concept of cross multiplication in proportions. So here we have a state law requires that on any field trip, the ratio of the number of chaperones to number of students must be at least 1 to 12. So here's the ratio that's given to us. If 100 students are going on a field trip, what's the minimum number of chaperones required? So the ratio they're talking about here is the ratio of chaperones to students. Okay. And the problem says that this has to be 1 over 12. So 1 chaperone for every 12 students. Now in your trip you have 100 students. So I'm going to put the 100 in the denominator, where I have the 12 also in the denominator. And I'll say, let's say the number of chaperones is x, unknown, which I want to find. And since these two are similar, they should be equivalent ratios, I can set them equal. And this is exactly the definition of proportion. Now I can cross multiply. I'll get 100 equals 12x, and solving for x here, you can divide both sides by 12. I'll get 100 over 12 equals x, and x will come out to be 100 over 12 would be 8.33. Okay, now the number of chaperones cannot be decimals. Chaperones are people. There cannot be 0.33 people, so you have to round it up to 9, which is D. Okay, and this, so you could ask, why not round it down to 8? Well, that would mean there are less number of chaperones than the ratio given in the problem. So 9 is the minimum number that would satisfy the constraint that the ratio has to be at least 1 to 12. If I put 8 for the answer choice, it means the ratio would be less than 1 to 12, and that would be the wrong answer. Next, we'll look at rates. So rates are a common type of ratio. So you might have seen something like miles per hour, a common rate for speed, miles per hour, or you could have words per minute. So what these things represent, basically you have this ratio which has words in the numerator, minutes in the denominator. Here you have miles over hours. Okay, so let's look at an example. Suppose someone types 100 words per minute, and you want to know how many minutes does this person need to type 225 words. Okay, so here you can set up a proportion. You know, this person types 100 words in 1 minute, and you want to know for 225 minutes how many, for 225 words, again with the proportion, same thing should go in the numerator, same thing in the denominator. So for 225 words, how many minutes? Okay, cross multiply, you'll get 100 words, 1 second. So you'll have on the right side, you'll get 225 words over 100 words, and on the left side basically you'll have the number of minutes needed, right? Because this number of minute in the denominator will go here in the numerator. On the left side, 1 minute doesn't matter because it's 1. So this will give me 225 divided by 100, that's 2.25 minutes, right? Okay, another way which in some instances might suit is if we write x for the unknown here, which is the minutes, right? Then x equals to 225 over 100 equals 2.25 minutes. Okay, same thing, actually exactly the same thing, except we have x, which might help in keeping track of things. Right. In these rate questions, always be careful about the units. Right. So the information in the problem might be given in, let's say, minutes, but the answers might be in seconds. So be careful about doing these conversion. You know, there's very easy to get tripped on these conversions. All right, so let's look at some GRE problems. Right, first one: if A apples cost C cents, how many apples can be bought for $D? So very typical GRE problem where you have these quantities in in algebraic terms, and your answers are also all in algebraic terms. Okay, right, so let's write down the information. You know, A apples, they cost C cents. Now how many apples, so I want to know how many apples can be bought for $D. Okay, so basically I'm looking for number of apples. Right, before I go into this problem, one thing we need to know is that $1 is equal to 100 cents. Okay, just like 1 rupee is 100 pesos, $1 is 100 cents. So if I have D dollars, that represents 100 D cents, right? Okay, let's set up our proportion. So I know A apples can be bought for C cents, and I want to know how many apples, so let's say X, can be bought for 100D cents. Got it? So basically I'm setting up my ratios. I know this ratio, A to C, A apples, C cents, that goes here on the left side, and this ratio, which should equal to the first ratio, which has an unknown number of apples, and D dollars, which is 100D cents, which goes here. Cross multiply, I'll have A times 100D equals X times. So here you do partial cross multiplication. You want X to be isolated, so I'm not going to move the C to this side. I'm not going to do that. I'm just going to move the denominator here, 100D, to this side. So I'll have A times 100D over C, and basically these are my number of apples that I can buy. So that's 100 ADC. There you go. Okay. Once you get good at these can be done in seconds, right? Okay, but the end thing is set up your ratio proportion, right, and solve for the unknown quantity. Right. Okay, next is a different type of rate problem. Let's see that. A hospital has enough pills on hand to treat 10 patients for 14 days. How long will the pills last if there are 35 patients? Okay, so again, ratios are there, but here there's a trick. So, well, actually not a trick, more that you have to be careful about. So you know, 10 patients, if I go ahead and set up my ratio, I know 10 patients last 14 days. If you go ahead and just do the regular proportion thing, then I have 13 patients, and I want to know how many days, right? How long means how many days the pills will last for 35 patients. But this is actually the wrong way. So if you do this way, the number of days will come out to be more than 14 days, and which is not the case. Since you have more patients now, 35 compared to 10, the days should go down. So what's happening is that basically the ratio in this proportion, the ratio is kept constant. So if your patients goes from 10 to 35, days will also go from 14 to some higher number, which is not right in the context of this equation. So here what you have to look at is the product, because the number of pills are constrained, right? If the number of pills were not constrained, you had unknown number of pills, you could go and do this way. But the pills are limited, so the days should be less. So you have to look at this product of 10 patients and 14 days. Okay, which comes out to be 140 patient days. Okay, so this tells you the supply of pills at that hospital. It has a supply that can last for 140 patient days. What's a patient day? Well, that's how many pills one patient needs in a day. So if I had only one patient, that hospital can serve that one patient for 140 days. But if I have two, then it would be half of that. That would be 70 days. Now, here we have 35 patients, so 140 patient days over 35 patients. So that means 4 days. Okay. So again, important to realize that we cannot use a proportion here. This would be wrong. Okay. And the reason being because the supply of pills is limited. You don't have unlimited number of pills. So your number of days have to be less than 14 days. So the right way to do this is to figure out this total supply that you have. So you have a 140 patient day supply, which you can serve one patient for 140 days. Now you have 35 patients, so you can serve them for 4 days. Right. Let's look at a similar problem in a different context. If 15 workers can pave a certain number of driveways in 24 days, so you have 15 workers and they can pave a certain number of driveways in 24 days. So 15 workers working every day can do a job in 24 days. How many days will 40 workers take? Okay. Again, will take working at the same rate to the same job. Again, here you can't set up a ratio or a proportion because you cannot set up a proportion because the number of days would be less, right? You have more workers working, so now the number of days should be less than 24. Again, you have to look at this product concept, which says that this job, which requires 15 workers for 24 days, is 15 times 24 is, we check, 360. Is a 360 worker day job. Again, what this number represents is that if I have one worker, then it will take that one worker 360 days to do the job. Okay, well, but I have 40 workers to work with, so 360 worker days divided by 40, which gives me 9 days. Right, so that's B. Another thing to realize is that we don't necessarily need to know the number of driveways that have to be paved, right? All we need to know is that this constant quantity, that this job of making driveways has this constant that 360 a worker working for 360 days can complete it. Okay, then I can divide by as many workers I have to find the number of days needed to finish the job. Okay, but important thing that the number of driveways is not important. Right, so that's all we have for ratios and proportions. For more practice, do exercise on page 293 in your Barron's 19th edition book. Alright, so goodbye till the next video. Thank you.